We've talked about looking at a polynomial and figuring out different features of its graph, like does it have x-intercepts that bounce or cross or both, and what's the end behavior like, how many turning points might it have. This video is about actually looking at the polynomial and actually graphing it. We're not doing exact graphs, we're doing good enough graphs, and I'll talk more about that later. The things we talked about in class is you look at a polynomial, you know its x-intercepts correspond to its zeros, whether it bounces or crosses corresponds to the multiplicity of the zeros. Its end behavior is determined by the degree and by the leading coefficient. Maximum number of turning points is determined by degree. We didn't talk about y-intercept, but we can use y-intercept to help us graph. We know y-intercept of any graph you get by plugging in a 0 for x and seeing what it makes y. And of course, if I'm trying to graph something, I always can make a table of values. I could always just plug in things for x and see what kind of y values I get, and then plot those as points and connect the dots. So let's dive in. A question might say sketch, it'll give you a polynomial. Maybe the polynomial is in standard form, maybe it's factored, maybe it's somewhere in between. You want to do all these things over here to help graph it. On a quiz, I might not actually ask all these things. Maybe I will, or maybe I won't actually ask each of these individually. You just have to know to do these things when you go to graph it. So first off, I'll find the y-intercept. Find the y-intercept means plug in a 0 for x and see what it makes y. So if I replace all of the x's with zeros, I get negative 0 times 2 times negative 1, which makes 0. If I plug in a 0 for x, I get 0, so my y-intercept is 0. So I plot the point 0, 0. That's my y-intercept. My x-intercepts come from the zeros of the function. When I look at my function, f of x equals negative x, x plus 2, x minus 1, zeros of something, 99% of the time I find the zeros by factoring. I see, okay, what makes this come out to 0? I factor it. In this case, it's already factored. My zeros are going to be 1, negative 2, and 0. So my x-intercepts are 1, negative 2, and 0. Of course, I already had that point 0 from the y-intercept. That's okay. At this point, maybe I make a mental note of the multiplicity of each. At 1, that's a multiplicity of 1, so it's even an odd multiplicity. Negative 2 had a multiplicity of 1, so it's odd multiplicity. And x had a multiplicity of 1, so it's odd multiplicity. I don't really care about the exact multiplicity, I just care about odd versus even, because later on that'll tell me cross versus bounce. I sketch the end behavior. Well, for the end behavior, I have to figure out what the leading coefficient is, what the degree is. If I have negative x times x plus 2 times x minus 1, if I multiply all of the big things, by that I mean if I multiply negative x and x and x, I'll get one term of what I would get if I actually FOILed it out. If I actually FOILed this out, I would get negative x cubed plus something, plus something, plus something, plus something. But the biggest thing would come from multiplying this, this, and this. So I know it's going to start off with negative x cubed. Based on negative x cubed, I know I have a negative leading coefficient. Negative leading coefficient means the right side is going to end going down. And I know I have a odd degree, which means that the left side is not doing what the right side is. If it's odd, they do not match, so the left side will go up. Now comes the kind of vague part. I wrote find other points. Find other points if you feel a need. If you think it'll enhance your graph. I'm not going to be like, oh, you need 3 points, you need 2 points. If you want to skip this part, you even could skip this part, as long as you feel like your graph's good enough to get a rough sense of the graph. I know that's vague, basically find other points if you want help in graphing it. You don't need to, but maybe I'm like, oh, I know my graph. I know what I'm doing at -2. I know what I'm doing at 0, and I know what I'm doing at 1. I wonder what I'm doing at -1. I wonder if the graph's above the axis, below. Maybe I want to find it just so that later on it will help me check to make sure I'm graphing things right. So at this stage, I find other points if I think that they would help me graph it better. In this case, I do think finding a point that corresponds with x equals -1 will help. So I'm going to plug -1 into the function. I do -1, -1 plus 2, -1 minus 1. All I did is I replaced all of my x's with -1. So this comes out to -1, 1, -2. A negative and a negative will cancel, but then there's still another negative. It looks like it comes out to -2. F of -1 is -2, so I'm going to graph the point -1, -2. -1, -2. That's helpful to me because say I were to not do that and I ended up with some graph, I ended up with a graph that looks like this. By getting that point -1, -2, now I know that that black graph I drew is wrong. So if I accidentally drew that black graph, extra points will help me realize, oh, that wasn't right. After I've potentially found other points, I connect the dots. I connect from one end behavior to the other piece of end behavior in a way that hits all my dots and bounces and crosses appropriately. So I start off at this arrow. I'll make this a little thinner, that way we can really see. Too thin. I start off with that arrow, and I just kind of connect the dots. At -2, it's an odd multiplicity, so I need to cross. I cross right through the axis. And then I hit this point, and at some point I need to start turning around because I need to hit this point. So maybe I'll cross it, I'll hit this point, and I'll turn around, and I'll go to 0. And then I say, oh, 0, that came from here. It's an odd multiplicity. So I hit that x-intercept, and then I cross through it because it was odd multiplicity. And I have another x-intercept here, so I better turn around and hit this x-intercept. 1 had an odd multiplicity, so I cross. And I end up with that end behavior. I know this was vague. I'm going to, for the sake of time, cut this video off and do another one after this.